Okay, this video will cover more derivatives and exponentials and logs, and we'll do a couple word problems, and we're also going to do a problem involving slopes of tangent lines, so make sure you have your calculator. Here we go. Section 4.4. Again, here are the four main derivatives for the section, and again, there are two PDFs attached from Mr. Martinez. Each PDF shows the proof of why the derivative of e to the x is e to the x and why the derivative of the natural log of x is 1 over x. This will be posted obviously online, so you can refer back to it. I'm going to look at number 32. And number 32, page 183, says a line with a slope. Right away, that means derivative. Right away, you should be thinking, slope, I need to find a derivative. Tangent, I need to find a derivative. Velocity, I need to find a derivative. It has a derivative, a line with slope m passes through the origin, and I left a space. If it passes through the origin, this is called, you probably don't remember, a direct variation. It's y equals some slope times x. Okay, so that's already our generic equation for this line. And it's tangent to the natural log of x over 3, and we want to figure out what is the slope. Okay, so I am going to start by finding the derivative of the natural log of x over 3. So the derivative of the natural log of x over 3 is 1 over the argument, 1 over the argument times the derivative of that argument, and the derivative of x over 3 is 1/3. And when you simplify that, you get 1 over x. When you simplify that, you get 1 over x. Okay, this represents the slope at any point on the tangent line. That represents the slope at any point. Okay, so y equals mx. So my mx is going to equal to my y, which is the natural log of x over 3. Y equals mx. Y is the natural log of x over 3. Mx, but I know m. M is 1 over x. Okay, m 1 over x times x, which is the generic variable. So 1 over x times x is 1. The natural log of x over 3. Okay, let's change forms. The base is e, so when you change forms, it's in log form. You change it to exponential form, you get e to the first equals x over 3. Therefore, x equals 3e. Okay, if x is equal to 3e, I'm looking for the slope. They asked you to find a line with the slope. What is m? M is slope. 1 over x. X is 3e, so 1 over x. X is 3e. 1 over 3e. Okay, the next problem I'm going to do is number 44. Next problem I'm going to do is number 44. Here we go. 44, I believe, asks you to find, 44 says use the technique of logarithmic differentiation to find dy dx. So you have 44, y equals x to the tangent of x. Okay, so logarithmic differentiation means they want you to take the log of both sides. So I'm going to use the natural log of y is equal to the natural log of x raised to the tangent x power. Okay, so now I'm going to differentiate. So if I differentiate both sides, oh, I'm sorry, I lied. Let's bring the tangent x in front first. Power property, I actually just used it in the previous video. Probably the most useful video. I'm sorry, useful property. I wouldn't say it's the most useful video. Okay, here we go. So now if I differentiate both sides, the derivative of the natural log of y is 1 over y dy dx. I don't know if you remember from the previous section or 2 sections ago, with implicit differentiation, I've got two variables. So if I'm going to differentiate y with respect to x, where's the x? I don't know. So the derivative of the natural log of y is 1 over y, 1 over the argument, times the derivative of the argument, and I don't know what that is. I'm going to use the, product property. So I'm going to do the tangent of x times the derivative of the natural log of x, which is 1 over x, plus the natural log of x. So the first tangent times the derivative of the second. Derivative of natural log of x is 1 over x, plus the second times the derivative of the first. And the derivative of tangent x, I believe, is secant squared x. Yeah. Okay, so I'm just going to do a little bit of a cleanup here. This is 1 over y dy dx is equal to 1 over x times the tangent of x. So that's really just tangent x over x. That's just tangent x over x. Plus the natural log of x times the secant squared of x. You need parentheses. If there's no parentheses, then it implies that you're taking the natural log of the quantity x secant squared x, and that's not what is happening. So we need to make sure we're using parentheses. Okay, now in order to isolate dy dx, I'm going to multiply both sides by y. That's going to be y times the tangent of x over x plus the natural log of x times the secant squared of x. Okay, that's Titus. He's not happy about something. And now I know what y is. Y is x to the tangent of x. Times the tangent of x over x plus the natural log of x times secant squared x. Okay, so I basically just did a bunch of differentiation knowing that the derivative of the natural log of x is 1 over x. The derivative of tangent x is secant squared x. And then isolating dy dx, multiplying both sides by y, and then you know that y was given as x to the tangent of x. You are done. Okay, so what we need now is your calculator, okay? So you're going to be doing probably a lot of pausing along the way. And which one am I doing? Number 52. Okay, so 52 talks about the spread of the flu. Unfortunately, this is a little bit too close to home for us. The spread of a flu in a certain school is modeled by the equation P of T equals 200 over 1 plus e to the 5 minus t. Okay. The first part says estimate the initial number of students. So this is going to be a plug and chug. So I want to know at time 0. And you plug in and you get 1.3 blah blah. Okay, so you can't have 0.3 people with the flu. Maybe they're people who are going to have the flu soon, or they have flu-like symptoms. But this is a little bit too close to home. So the answer is 1. Okay, so here's what happens with part B. How fast is the flu spreading after 4 days? How fast is the flu spreading after 4 days? So you need to find the derivative. Okay, so I really don't like the quotient rule, so I changed this into a product rule problem. Feel free to use the quotient rule, push pause, or fast forward it, see if you get the same answer. So I did this as the P of t is 200, 1 plus e to the 5 minus t to the negative 1. Okay. Product rule. The first, 200. The 200 times the derivative of 1 plus e to the 5 minus t. Okay, here we go. Chain rule. Negative 1 comes in front. 1 plus e to the 5 minus t. Decrease it by 1, so you get negative 2. Then times the derivative of what's inside. Okay, so the derivative of what's inside. Derivative of 1 is 0. The derivative of e to the 5 minus t is e to the 5 minus t times the derivative of the exponent, and the derivative of the exponent is negative 1. Okay, so this is going to be negative, negative, positive. 200 e to the 5 minus t all over 1 plus, oops, this is just kind of messy. I just want to clean this up a little bit. 1 plus e to the 5 minus t squared. Okay, and that is indeed the derivative. You could have gotten the same exact thing using the quotient rule. So it says, how fast is it spreading after 4 days? You can do that without me. It's a total plug and chug. The p prime of 4 is going to be approximately 39 if you've plugged it in correctly. Okay, the last part asks you, when will the flu spread at its maximum rate? What is that rate? Okay, so that's the derivative. So push pause, plug it into your calculator. I'm going to move this so it's a little bit easier background. Okay. Do a zoom 6. And that looks pretty messed up. Oh, actually it's not too bad. It's not too bad. But let's do some fixing of this. First of all, we're talking about time in days. There's no such thing as negative time. So I went to my window and I automatically adjusted my x minimum to be 0. My x maximum, I just kind of played around with it a little bit. Another way that you can check it out is your table, so second graph. And it's like, I was just looking, all of a sudden I'm getting these like really super, super small values. So I said, okay, let my window go from 0 to 20, and I went by 2s. Can't have negative people infected. You already figured out that at 4 days there were 39 people. So I just said, okay, let's just do 100. Voila. Wait, how did I get so lucky? I literally just played around. I used the table, I used the information from the problem. They want to know the maximum. Okay, oh, can you even see that? Can you see this? Maybe? Okay, now you want to know the maximum. Review. Second, trace. 4 for maximum. Arrow to the left. Ask for a left boundary. Arrow to the left. Great, that looks good. Push enter. Arrow to the right. Great, looks good. Enter. Guess. I'm going to put my cursor pretty close to where I want. Enter. And it tells you the maximum is very conveniently at 550. The max is at 550. Perfect. So if the maximum is at, oops, how about I unzoom, which is going to take me longer to do than to zoom. All right, so I can't get it to unzoom, and I don't know why. Here we go. So here we go. The maximum is at 550. This means that day 5, 50 students per day are catching the flu. There you have it. All right, you guys, last video. Come to office hours if you have questions, and I will be posting solutions sometime tomorrow. Well, for you guys, that's Monday. All right, you guys, take care.